working now. Yeah.
Hello, womENcouragers. Thank you for coming in from such a nice garden with coffee. So, we are very proud to have Toni chairing this panel, How HPC Can Change the World, with our panelists, Rosa, Lorena, and Jazmin. So, when you're ready, we will start. Thank you.
Thank you, my dear.
Thank you, Toni.
Oh, my pleasure. I'm going to put my bag. I'm going to put my bag down there so I don't get it. Oh, thank you. Shall I just get going? I'm going to say a few words to get going anyway. Yeah, okay. Thank you all for coming back from coffee. I know how important a coffee is on a Friday afternoon at the end of a long week, believe me. Sometimes I feel it's the most important part of the week is that Friday afternoon coffee. To me, I know I would say this because I'm standing up here, but to me this is the single most important part of the week. I was absolutely honored when Rianne asked me if I would chair this session because for many, many years I have said the reason I do HPC, the reason I get up in the morning is because I really believe that HPC can not just change the world, but is actively changing the world and making it a better place. Just before I came up on stage, I was given this book as a thank you from womENcourage for doing this. And it really struck me. This book is The Legacy of Working Women in the Historic Old Quarter of Barcelona. And the subject of this book sort of epitomizes why we're doing what we're doing this week, which is recognizing what women do. And therefore showing you that women have something to contribute and that you can follow in their steps and contribute as well. A lot of the time in history, women have been invisible. Thankfully, that is changing. The computers in the 1960s that, as we heard from Alison earlier today, that were actually women, are now recognized as computer scientists. They weren't computers, they were human beings, and crucially, they were women contributing valuable expertise to the forwarding of mankind's knowledge. So here today, we have 3 real people. These are people that you could be in a few years' time. They're not just people that are amazing superstars who are astronauts that, are only 1 in a million people ever get to be. These are people who are actually changing HPC today. And for the next 45 minutes, you get to ask them pretty much any question you like about HPC. They are allowed to say, I don't know. I've told them that. They don't have to know everything. But really, I want to start off by asking them to introduce themselves, asking them to tell me a little bit about how they believe what they do changes the world, what they do day to day. So, Rosa, Badia.
Thank you, Toni. So I'm Rosa Badia, as Toni said. I'm the world leader of the Warflows and distributed computing here in Computer Science Department at the Barcelona Supercomputing Center. And basically what we do is trying to develop tools to make it easier to program applications to run in these big machines that you've seen the descriptions in the keynotes today by Alonso and also by Catherine. No? So these machines are not easy to execute applications there. No? So what we try is to provide programming tools that help these scientists to develop their applications. And I think this has an impact in society because, of course, this enables the scientists to focus on their problem actually and not in the tools that are the supercomputers.
My name is Lorena Alonso, and I'm a research engineer at the Computational Genomics group in the Barcelona Supercomputing Center. The aim of our group is to study.
I think it's not working.
No? Can you hear me?
No.
Yeah? Okay. So I'm Lorena Alonso. I'm a research engineer at the Computational Genomics group at the Barcelona Supercomputing Center. And the aim of our group is to try to improve in healthcare and medicine in order to study and to prevent, detect, and treat at the end the diseases. And we use high-performance computing because our main goal is to understand why some individuals are more likely to develop a particular disease than other ones. And we need to analyze thousands of samples and imagine that only one sample of one patient weighs between 300 and 400 gigabytes. And we need to store it and also to analyze it. So that is why high-performance computing is important for us.
Okay, hello everyone. It's great to be here. I am Jazmin Aguado-Sierra. I work at the Computer Applications in Science and Engineering department here at BSc as well. And I work in, well, I develop electromechanical models of the heart. Well, not only electromechanical, but also including fluid. Not only of the heart, but also anything on the cardiovascular system. So I'm mainly focusing on the application. So I'm a biomedical engineer by training, then did PhD on bioengineering. So if you ask me about the specifics of architecture, parallelization, and that, I would be a little bit puzzled. But my job here is to actually create models that actually represent the physiology so that they are actually applicable and they actually solve real problems. So it is very important to be part in this multidisciplinary area if you want to be able to produce something that will impact patients or will impact the diagnostics and all of these things. So I think, well, HPC is pretty much the only way to do in silico simulations that otherwise are absolutely impossible to do in patients or in animals, because animals really are not humans, and there's a big difference between them and us. So it's also a big step to try to eliminate all those things that are a bit old now, and try to substitute that with all of the knowledge that we have now, and to try to apply it for medicine in this case. So anything in bioengineering, well, particularly cardiovascular system, I'm in charge of just making it as physiological and as close as possible as you can. So, yeah.
Thank you very much for the introductions. I want to take what you said a little bit further. You've all described a little bit about what you do. And I'm going to start with Jazmin at the end and come the other way this time. I'd love for you to now tell us a little bit about what really inspires you to do what you do. What keeps you getting up in the morning on those mornings that you really don't want to get out of bed? What makes you carry on in HPC?
Well, it's a tough job, that's for sure. What I love is that you're actually able to do things that very few people can actually do in the world. Why? Because you have access to big infrastructure, and anything that you can imagine, anything that you can think, anything that you can question, you can go and try it there with your models. And to me, that's absolutely fascinating. Like, I was at a congress on medicine here, the cardiology congress here, and you see the questions that doctors have suddenly. And you see that and you think, oh, I can put that in a model and actually give them a quantification of what they're looking, and that can actually help them improve the therapeutics or the diagnostics of their patients. And then you start questioning things, and the best thing is to actually be able to implement them. It's a tough work because systems are very complex. It's not just putting in the mathematics. You have to think about many other things, particularly when you're targeting healthcare. But the most amazing thing is, like, you can try anything that you want. I mean, you can just create a model, run it, let it run for whatever number of hours it's required, and you get answers that may actually sometimes help someone. So that's the best thing for me.
Thank you, Jazmin. Lorena.
Well, during my day, I used to create a database in order to store a lot of variants and mutations that we found in the human genome, to understand how cancer, diabetes, and also VIH affect to the human. I'm working with biologists who need to have this information ready to analyze. It's complex information, and it's some information that must be also treated in supercomputers. So this is what motivates me to go to work every day, because I think that they are not capable of doing some technical part that we are capable of doing with giving some instructions to those supercomputers that are, as Jazmin said, that are not affordable for everyone, but you cannot avoid it to solve some of the problems that are concerning a lot of fields in our lives, and that try to solve the most important and complicated problems that are affecting our society each day.
Thank you, Lorena. Rosa.
Well, I'm here the more senior of the group, and during all my career I've been very inspired by my job. And at the beginning I was more like worried about, okay, I want to do progress on my PhD, and I want to publish papers, and I want these papers to have impact. And later on I started to collaborate with projects, mostly European projects, so I said, oh, that's great, I can collaborate with other people, European level and even worldwide level, and make progress and develop tools that others will use and so on. So this was even more inspiring. But recently, even it's more, because what we are doing now is a lot collaboration with the applications department, especially at BSc, for example, with the life science department. And one of their applications, for example, is a genome-wide association studies that probably Lorena could tell you more about it, but I know that they need that it's able to execute in parallel in supercomputers or in distributed platforms. And they have ported or developed a version on top of our programming model. And I was more worried on, well, how it's going to behave, it's going to be scalable, it's going to be able to use more nodes, it's going to be able to be run in different environments. So I was more worried about the technical aspects, but also when I spoke to them recently, I discovered that they have been using this application for doing some experience on analysis of rare diseases. And for example, one of the results is that they determine the chromosome, which is the one that causes a type of diabetes. And for me, this was, wow, this is really helping the science to do progress. So as I said, I've never had problems to come for my work, but recently it's even more satisfying.
Thank you. That's quite inspirational. There is a theme coming out here of life sciences, and I think this is one of the things that I've noticed since I started in HPC is life sciences really now are, for the first time, properly using HPC. Before, there were a few people from life sciences coming in, and I think this is something we're seeing across HPC in general, is it's now reaching almost every single sector. It's not just science anymore, it's also humanities. So on that note, because one of the things I've noticed is that there's no single type of person that is an HPC person. There's no HPC undergraduate degree that I know of. In line with that, do you think there's something about you as an individual, perhaps how you've come through university, the training you've had, or just an experience you had, that means that you are a little bit unique and it gives you an edge in problem solving, because none of us are the same? I'm going to start with Lorena this time.
In my case, I think that something that particular that defines me is my horizontal profile, because I'm a mathematician specialized in applied statistics and in particular focused in bioinformatics and biostatistics. but during my last 6 years, I've been working as a web developer and data analyst in financials. So my master degree was which gets me into the HPC world, and I think that it is very important to have a multidisciplinary team, but also that try to be multidisciplinary by yourself in that world.
Thank you. Let's go to Jazmin.
Well, I fully agree in the sense that we have to be quite multidisciplinary. I don't consider myself a particular HPC person. Probably during my career, I was never really focusing on the HPC side of things. I was mostly focusing on the questions of physiology, and by one reason or another, I ended up here at the HPC Center. And I think it's been a really interesting experience, or at least a very, very good experience. You have to learn a lot about the actual HPC application, about the codes, about the efficiency, about trying to run your problems as best as you can, which wasn't a thing I had ever really thought about. So I believe there's not, well, in my experience, there's not an HPC person, or maybe there might be out there, I don't know. But the fact that you can use a tool as best as you can to answer different questions or to create better software or better tools for that, I think that fully makes you an HPC advocate or something, I would say.
Thank you. Rosa.
In my case, I think, although I'm the less multidisciplinary, I think that during all my research career, I've been like not jumping from topic to topic, but just changing slightly. And I've been working on even design of circuits at the beginning of my career, and then more on performance tools, and then probably then now there's a lot of times now, a long period, I mean, working on programming models, no? But still, I think I've been able to see the different aspects, more pure HPC, but the different aspects. And some of my colleagues, I would say male colleagues, usually don't have this, it's not that they cannot do it, it's that they prefer to focus in a single problem, usually, in a single topic, and stay there. No? I think females tend to be more flexible on moving from topic to topic. And the other thing I've seen I'm quite good is to networking and to being able to start new collaborations and attending meetings and making connections, even not to myself. So maybe I knew somebody else and it's interested in a topic and say, but I have a colleague at BSc that's working on this, and I make the connection. And I think not everybody is doing this that way. Even inside BSc, I think I've been collaborating basically with all departments and most of the different groups inside my department. So I think this is very good, and it's not always the case that happens, and it's very good.
Yeah, I think all three of you have hit the nail on the head, as I would say there, about why we do HPC. Jazmin, you mentioned it's always about the question, and what I took from Rosa's point there was it's about curiosity. And I think a lot of what we do in high-performance computing is driven by our curiosity, and therefore, the more curious you are, although you might be one of those 2-year-old children that goes, why, all the time, but that's actually why we do exactly what we do, because we want to know why. So I do want questions from the audience. I'm going to ask them one more, but get ready. I want lots of questions. One more question that I really want to ask is, have you faced any challenges, particularly maybe when you first entered your career? Have they given you a particular edge, or are they still a challenge that you face? How did you overcome them? I'm going to start with Rosa this time.
Okay, so challenges in HPC, you have a lot of them, no? From if you have to do any research topic, of course, it's a challenge. You need to look for solutions. study the related work and so on. And then inherently to the HPC systems is the interaction with them, which it's not always easy, no? So interacting with operations people, that asking them to enable you to try new things, and that's why also it's important to have prototypes, like now in the new Mare Nostrum machine, we will have like more specific prototype for the research, no? So probably it's this, that most supercomputers are machines in production, so, and you cannot pretend that they will be available for all your research, no? So probably this is the more challenging aspect.
And it's a real aspect that never goes away either. It's there all the time. It's one of the things about high-performance computing is very much that it is, by definition, always the forefront of computing. We are making the change that is going to be what ends up in your phone or your laptop in a couple of decades. So that's a fascinating take on that question. Lorena.
In my case, I think the most challenging problems that I had arriving to the HPC world was, first of all, trying to communicate with and interact with supercomputers. At Barcelona Supercomputing Center, it was Mare Nostrum 3 and now Mare Nostrum 4, so adapting to the new systems, returning to Linux operative systems because I was working in Windows as a web developer and data analyst. And also to try to get the best profit of any job that you run into a supercomputer to get your results faster. And finally, as I said before, we are multidisciplinary groups, so I need to adapt to the background, to the computational genomics background, and to understand not only the scripts that I was going to do, but also the biology that is behind these scripts.
Thank you. Jazmin.
Challenges also on my side of the applications, they were huge. Just trying to get used to send your models to this big machine, trying to actually get the physics right for biological systems, which it's not that easy. It has always been a challenge of you have to create new methods, new physics, new models, if you want to try to answer complex questions. And well, that's partly the interesting thing, the challenge, because otherwise the job would be done and you would go back home. So also trying to get everything more advanced, better, and well, in HPC faster. So yeah, it's challenging, but I think it's cool. So anyway.
Thank you. Okay, I'm very interested in what you have to ask. We've heard a lot about HPC today. I hope you feel able to ask a few questions of these wonderful women up here about anything they said, or about working in HPC more generally, or about maybe something you've heard earlier today from some of the other inspirational speakers. I'm sure they'll do their best to answer, although we can't guarantee they can because they're not experts necessarily in that. So, do we have a microphone? We do. Fantastic. Can we take this question down here?
Hello, I'm Adriana Wad from the University of Southampton. I suppose my question is for the whole panel, but especially for Rosa Maria, because you have been a long time now in this sector, and it's about how sensitive it is to the hypes and the reinventing the labels that are in fashion, and and how does influence the seeking funding for your research. Like, I'm thinking about how we used to talk about parallel computing, and then we started talking about grid, and then we started talking about cloud. But essentially, we're talking about the same thing, how you divide your problem into things that you can process separately and then collect together and so on. So from that point of view, how the challenges I'm interested in and seeking the funding to advance the field. Thank you.
Thank you, Adriana. It's a very interesting question. Yeah, when I said the name of my group, it's now Warflows and Distributed Computing, because before was grid computing. So basically, a distributed system can be anything, no? Can be a cluster, can be a cloud, or can be a grid, no? And we have all these buzzwords, and I think the buzzwords are relevant during some period for publications or for funding, because now, for example, the European Commission was seeking for projects on the area of cloud, no? And even changing now to IoT or fog computing and other buzzwords, no? But I think if you have a solid project that works on a topic that is relevant, you will exist. I mean, I started doing my programming models for the grid environments, but also worked for Cell Processor, which is the processor of the PlayStation 3, and also worked for it's working for the cloud, and it's working for supercomputers. So if you, what do you do with your research should not be totally bind to the actual technology, I believe, because a research topic should be abstract enough that could map on different technology. Because cloud is a technology, no? And of course it's very interesting because it's selling computing, and in terms of selling, it's much better to speak about cloud than was speaking about grid. But probably will eventually will finish, and another technology will be in the market, okay? But if what you do and your tools, your research are solid and abstract enough, you will be able to continue and get funding or whatever in the different topics. So I suggest that my idea is this, no? That you should not be worried too much about what is the last trend, but to see more the evolution of the technology and how your research can contribute to this.
Thank you, Jazmin.
In the case of the applications of what I do, I think all of these buzzwords, and that is a big problem in our side for the funding. People have been selling all of these patient-specific, all doing dancing models to treat or to aid in diagnostics. And so, and many times for the commission, that problem is solved. I mean, some people did some models before, and that is solved. Let's move to the next thing. While when you look at the models, when you look at the details, there are many things that haven't been solved, really. There are many things that haven't been properly thought to try to get access to doctors, probably to use it. I mean, there are so many more details that no one takes into account. And then the commission is moving on to the next buzzword. And then there's so many questions. There's so many other people trying to work on those things, and then you try to apply with your ideas of trying to make models better, to trying to be more predictive, to trying to do things, and then that becomes old topics. I think in my area of research, I think there is a big problem that people have been overselling the results, overselling the ideas, and then that absolutely impacts back on the research of the rest of the world. So I don't know how we can solve that problem, because for us it is an issue. I don't know, the more we get in touch with the commission and tell them, like, well, you see, it's not that you're saying like, oh, that work doesn't work, it wasn't good. No, I mean, it was the funding thing. I mean, the first models to start doing these things, but there is room for improvement. There are more things you can do about it, and then you don't have to move on to the next buzzword just because of that. It's hard to convey that, and that is something that definitely affects us in our field. And it's a difficult question. It's a difficult thing to make people notice that. I mean, now people are starting to notice that, yeah, you move on to the next buzzword, but then you end up with partially done science. And then